Here are 10 possible important questions with answers for Class 12, Semester 4, Physics of the West Bengal Council of Higher Secondary Education, WBCHSE Board, along with brief explanations. These are based on the syllabus and recent exam patterns. You should still continue your full syllabus revision and practice other questions. 1. Question. Explain the phenomenon of total internal reflection. Derive the expression for the critical angle when light passes from medium 1, refractive index N1, to medium 2, refractive index N2. Answer. When light travels from a denser medium, higher refractive index, into a rarer medium, as the angle of incidence increases, the angle of refraction increases until it becomes 90 degrees. Beyond that incidence angle, no refraction occurs and all the light is reflected internally. This is total internal reflection. From Snell's law, N1 sine theta c equals N2 sine 90 degrees equals N2. Sine theta c equals N2 divided by N1. Theta c equals sine -1 big bracket N2 divided by N1 big bracket key point. TIR happens only when light moves from higher to lower refractive index and incident angle greater than critical angle. 2. Question. In the photoelectric effect, why does the photoelectric current saturate? State and explain the Einstein photoelectric equation. Answer. When light of sufficiently high frequency falls on a metal surface, electrons are emitted. As the anode-cathode voltage becomes more positive, more emitted electrons are collected and current increases until all emitted electrons are collected. Further increasing the voltage does not increase current, hence saturation. Einstein's photoelectric equation. HF equals small symbol plus 1 divided by 2 mv squared max. H is Planck's constant. F is frequency of incident light. Small symbol is the work function of the metal, minimum energy to free an electron. 1 divided by 2 mv squared max is the maximum kinetic energy of emitted electrons. This shows that kinetic energy of emitted electrons depends linearly on F and is independent of light intensity, once above threshold. 3. Question. Define binding energy per nucleon and explain how it varies with mass number. What is its significance in nuclear fission and fusion? Answer. The binding energy of a nucleus is the amount of energy required to break it into its constituent protons and neutrons. Binding energy per nucleon equals total binding energy divided by number of nucleons. As mass number increases, binding energy per nucleon rises, reaches a maximum around iron or nickel region, and then slowly decreases for heavier nuclei. Significance. In fusion, light nuclei combine to form a heavier nucleus with higher binding energy per nucleon. Energy is released. In fission, heavy nuclei split into lighter nuclei that have higher binding energy per nucleon. Energy is released. Thus, energy release in nuclear processes is tied to increasing binding energy per nucleon. 4. Question. With the aid of a diagram, explain the working of a p-n junction diode in forward bias and reverse bias. Mention one application of each mode. Answer. Forward bias. P side connected to positive terminal, N side to negative. The potential barrier is reduced, charge carriers cross the junction, current flows. Application. Rectifier in power supplies. Reverse bias. P side negative, N side positive. The potential barrier increases, very little current, leakage, flows. Application. Zener diode. In reverse breakdown used for voltage regulation, although strictly Zener is specific. A diagram should show depletion region narrowing, forward, or widening, reverse, direction of current carriers, etc. 5. Question. What is the resolving power of a telescope? Derive the expression for the resolving power of a circular aperture, diffraction limited. Answer. Resolving power is the ability of an optical instrument to distinguish between two close objects. For a circular aperture of diameter d, under diffraction limit, the angular resolution, or minimum resolvable angle, is given by the Rayleigh criterion. Theta min is approximately 1.22 lambda divided by d. Hence, the resolving power, reciprocal of this, tauarity, diffraction, unfamily, more strong mean. But in atom, where small gaps, electrons can jump easily across to conduct. Channel medium, understand about conductor, and insulator in a solid. 6. Question. State and explain the principle of a transformer. Why must the cores of practical transformers be laminated? Answer. A transformer works on the principle of mutual induction. An alternating current in the primary coil produces a changing magnetic flux in the core, which induces an EMF in the secondary coil. If the ratio of turns is NP and NS, VS divided by VP equals NS divided by NP. Laminated core. The core is made of thin, insulated laminations to reduce eddy current losses, currents induced in the core itself by changing flux. Laminations increase resistance to those currents, fewer losses, higher efficiency. 7. Question. What is de Broglie wavelength of a particle? Calculate the de Broglie wavelength of an electron accelerated through a potential difference of 150 volts. Mass of electron equals 9.1 times 10 to the negative 31 kg. Charge equals 1.6 times 10 to the negative 19 C. Planck's constant equals 6.63 times 10 to the negative 34 Js. Answer. The de Broglie wavelength lambda equals h divided by p, where p is the momentum of the particle. If an electron is accelerated through potential difference v, its kinetic energy is equal to ev. Then momentum equals square root of 2mev. So lambda equals h divided by square root of 2mev. Lambda equals 6.63 times 10 to the negative 34 divided by square root of 2 times 9.1 times 10 to the negative 31 times 1.6 times 10 to the negative 19 times 150. 9.1 times 1.6 equals approximately 14.56. Times 150 equals approximately 2,184, and times 2 equals approximately 4,368. So 10 to the negative 50 equals 4.368 times 10 to the negative 47. Square root is approximately square root of 4.368 times 10 to the negative 23.5 is approximately 2.09 times 10 to the negative 23.5 is approximately 6.6 times 10 to the negative 24, approximately. Thus, lambda is approximately 6.63 times 10 to the negative 34 divided by 6.6 times 10 to the negative 24 is approximately 1.0 times 10 to the negative 10 meters equals 0.10 nanometers. So, de Broglie wavelength is approximately 0.10 nanometers approximately. Interpretation. Very small wavelength demonstrates wave nature of matter for fast electrons. 8. Question. Explain what is meant by the term band gap in semiconductors. How does the conductivity of an intrinsic semiconductor vary with temperature? Answer: the band gap is the energy difference between the valence band and the conduction band in a solid. In semiconductors, electrons must acquire energy at least equal to the band gap to jump from valence to conduction band and conduct electricity. In an intrinsic or pure semiconductor, as temperature increases, more electrons gain thermal energy to cross the band gap, more charge carriers, conductivity increases. Thus, conductivity increases rapidly with temperature, unlike metals where resistance usually increases. Hence, semiconductors show negative temperature coefficient of resistivity or increasing conductivity with T up to a point. 9.